Let's discuss two more questions. What is the value of 1 upon 1 plus cot square theta plus 1 upon 1 plus tan square theta? This is a very small question. I think you can see the identity directly. You can substitute, simplify a little bit and get the answer. Let's do it. So we want to know the value. So 1 upon 1 plus cot square theta plus 1 upon 1 plus tan square theta. Done? Simple. Now the identity is what? Here it will be cos sec square theta, right? And here it will be sec square theta. Simple. So let's substitute that. Here it will become 1 upon cos sec square theta plus, and here it will be 1 upon sec square theta. Now what? We know that 1 upon sec theta is equal to what? Cos theta, and 1 upon cos sec theta is equal to sin theta. Done. So what I'm going to write, make sure you remember this square because square over here. So here it is cos sec theta. So cos sec square theta will become sin square theta. So sin square theta plus 1 upon sec square theta, that will become cos square theta. Now again this is the identity, sin square theta plus cos square theta. Okay, sin and cos, square square, plus and theta value is same. So what's the final answer? That is 1. So value of this is what? 1. Let's recall one more time. 1 plus cot square theta, we know cos sec square theta. 1 plus tan square theta will be substituted by sec square theta. Done. 1 upon sec is equal to cos, 1 upon cos sec is equal to sin. Substitute and apply the identity again. Done. Let's do the next question. So prove that tan raised to 4 theta. Okay, tan raised to 4 theta. We don't have any identity for tan raised to 4 theta so far, right? Tan raised to 4 theta plus tan square theta is equal to sec raised to 4 theta minus sec square theta. Okay, let's try to solve whatever we can do so far. Let's do it. So here let's write with the LHS tan raised to 4 theta plus tan square theta. Done. Now what to do over here? Suppose if you have something like x raised to 4 plus x raised to 2. So how would you do it? You will take x raised to 2 common, right? And you will be writing as x square into x square plus 1, right? I'm comparing with the algebra because we know algebra rather than trigonometry now. So this is the same thing I'm going to do. I'm going to do tan raised to tan square theta common. Now see, tan raised to 4 theta I can write like that. Tan square theta into tan square theta plus tan square theta. Now you can see that tan square theta is present over here and here 2 times as well. So I can take common, right? So let's take tan square theta common. So tan square theta common, and here if I take tan square theta common, this tan square theta is still over here, right? If you hide it, so tan square theta here, so tan square theta. Then if I take this whole term common, what I'm going to write? See, if I take x square common, I'm going to write 1. If I take tan square theta common, what I'm going to write? Plus 1. So I hope you are clear with this step. Very important step it is. Now you know that tan square theta plus 1 is equal to what? Sec square theta? Yes. So let's replace it here, tan square theta and sec square theta. Now, but we don't want tan square theta in the answer. We only want sec, right? So let's use this identity in the different way. Okay, let me write the identity first. So identity is sec square theta is equal to 1 plus tan square theta. Let's make tan square theta subject. So this 1 will go there and it will become minus. So sec square theta minus 1 is equal to tan square theta. So instead of tan square theta, what I'm going to write? Sec square theta minus 1. So let's write here that tan square theta. So what I will be replacing with? Sec square theta minus 1 into sec square theta as it is. Done. Now Let's use the distributive property. Multiply sec square theta with this first term, then multiply sec square theta with the second term. So raised to 2 and raised to 2. It will combine it and it will make power 4. So here sec raised to 4 theta minus 1 time anything you multiply with 1 going to remain as it is. So that is sec square theta. And you can see that is the RHS. Right? Let's recall this step. In this question, I used the one identity 2 times. One identity I used 2 times in a different form. Let's recall 10 raised to 4 theta plus 10 square theta. So you can compare with the algebra and we need to take something common. Now how to take common? I have divided 10 raised to 4 into 2 factors. 10 square theta into 10 square theta. So we can come to know that there is something common between these 2 terms. Take that common out. So what's left? If I take this common out, there's only 10 square theta and plus 1. Simple. So here identity is there sec square theta. So replace with it. For 10 square theta also same identity but in the different form. That is sec square theta minus 1. Replace and multiply and get your answer. Prove that tan theta over 1 minus cot theta plus cot theta over 1 minus tan theta is equal to 1 plus sec theta and multiply by cos sec theta. So let's start with the LHS. LHS is equal to tan theta over 1 minus cot theta plus cot theta over 1 minus tan theta. Be careful while you write the question. So first of all, I am going to convert this tan theta in the form of sine and cos. You can see on RHS there is sec and cos sec. So first we need to convert into sine and cos, and that sine and cos I am going to convert into sec and cos sec. So tan theta is equal to sine theta over cos theta and denominator 1 minus cos theta over sine theta. You will be getting fractions in fractions, right? Numerator fraction, denominator fractions. No worries, we'll simplify. Then cot theta is equal to cos theta over sine theta and denominator 1 minus sine theta over cos theta. Done? Simple. Now first of all, what I'm going to do, I'm going to keep numerator as it is. I'm not going to bother about that. So let's only solve the denominator first. So in denominator it is 1 minus, so I need to take LCM. There will be 1 and multiply with sine theta. There is 1 over 1 and multiply with cos theta. Done. So let's do. Here sine theta and cos theta as it is. And denominator, sine theta will come into numerator. So sine theta minus cos theta, and denominator what? It is sine theta plus here let's do it one more time here. So cos theta as it is over sine theta as it is, and in denominator it is cos theta minus sine theta, and denominator what was the LCM, which is cos theta. So this cos theta will go into numerator, this sine theta will also go into numerator. So sine theta into sine theta, it will be what? Sine square theta over cos theta as it is, and in denominator sine theta minus cos theta. Done? Let's do further, which is plus here cos theta into cos theta, that will be cos square theta, and denominator it is sine theta. Now what about the common denominator? That is cos theta minus sine theta. Now see, one thing you need to observe, sine theta cos theta sine theta, but signs are different. So what I'm going to do, I'm going to change the sign of this into sine theta minus cos theta. For that I need to change their sign. This will become negative, this will become positive, and this negative will also become negative. So let's do it. Here numerator I am going to keep as it is, which is sine square theta over cos theta, and denominator it is sine theta minus cos theta, and this will become minus cos square theta over sine theta and sign will be changed and it will be what? Sin theta minus cos theta. Done? Now let's simplify further. So we have common denominator. So when we have common denominator, we add or subtract the numerator. So let's do it. So here sin square theta over cos theta minus cos square theta over sin theta, and common denominator, which is sin theta minus cos theta. Done? We simplified. Now let's do numerator simplification. This sin theta will be multiplied over here, this cos theta will be multiplied over here, and it will come into denominator. Let's see how. Sin square theta into sin theta, that is sin cube theta, minus cos square theta into cos theta, that is cos cube theta, and denominator, this sin theta as it is minus cos theta as it is, into what? These two terms will come down, which is cos theta into sin theta, because that was my LCM. Remember, this is my LCM. We are multiplying this because there is no cos sin theta in denominator, there is no cos theta in denominator, so multiplied, right? And we get that in the denominator, that LCM in denominator. Now what to do? Interesting question. A cube minus b cube, we are going to use that identity of a cube minus b cube is equal to a minus b into a square plus b square plus ab, right? I am going to take sin theta as a cube and cos theta and cube as well. So that is sin theta minus cos theta, and here sin theta square plus cos theta square plus multiplication. Let's do it. It's very confusing when I speak. Let's write it and clear it out. Here the term will be little longer, so I'm writing in this way. So here it will be a cube minus b cube. So first I need to do what? A minus b. So sin theta minus cos theta, that's done. Now I need to take square. So sin square theta plus cos square theta, done. Then product of it, plus sin theta cos theta, product is also done. So everything is done about the numerator. Let's write the denominator as it is, because there is no change. Sin theta minus cos theta, and what's left? Cos theta sin theta. Done. Now can you see there is a one common factor in numerator and denominator? That's why I use the identity. So I can do cancellation. It's done. So what's left? Sin square theta plus cos square theta. Now sin square theta and cos square theta, what's the identity for it? I can replace it 1. So what's left in numerator? Let's talk about the numerator. Numerator, there is only 1 now. This term is gone. So for this term there is first 1 plus sin theta cos theta. So sin theta cos theta, and denominator, what's left? Cos theta sin theta. So cos theta sin theta. Done. Now let's divide individually. Here it will be 1 over cos theta sin theta plus here sin theta cos theta, and denominator what? Cos theta sin theta. So you can see that cos theta cancel, sin theta cancel, and here 1 upon cos, which is sec theta, 1 upon sin, that is cos sec theta, plus 1. So if you see, we need to prove that only in the RHS. Let's rearrange it. 1 should be first. 1 plus sec theta cos sec theta is equal to my RHS. Simple. This sum was little longer because we used many concepts over here, which is first about the conversion of tan into sin and cos. Then we did LCM, fractions were coming in each and every step, right? So we converted, we took the LCM, then simplified further. We need to get common denominator, so we can simplify the numerator. That's done. Afterwards, identity, very important. A cube minus b cube. You need to learn this identity. We can use it any point of time wherever square and cube is coming. Then identity, then see if anything we can take common or we can cancel it. Then Sin square theta and cos square theta, we know it is 1, so substitute there. Then we need to divide this numerator by denominator individually. So individually you divide, it will be the reciprocal, and here it is 1 because everything will be cancelled out. So that is my RHS.